Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to discuss what is termed as discrete uniform distribution. So let's dive into the video. So what is termed as discrete uniform distribution? Discrete uniform distribution is used to model finite number of possible values of a random variable with its equal probabilities. So that is just telling us that if you have different observation of what for a particular random variable, all these observations that we have for that particular random variable must have what? An equal probabilities, right? So for instance, if you have x1, x2, x3, x4, right? The probability for x1, x2, x3, x4 must be what? The same, right? So how can we define discrete uniform distribution with 8 PDF? So let's go into it mathematically. We are saying that a random variable x has a discrete uniform distribution if each of the n values in its range says x1, x2, to xn has what equal probabilities, as I was saying. So you see here you have different observation for the random variable, that is x1, x2, to xn, and this distribution is trying to tell us that this random variable must have what equal probability. So if we have 1/2 to be our probability, then our x1 must be 1/2 with its probability. Probability for x2 must be 1/2. Probability of what? X sub n must be equal to what? 1/2. That is discrete uniform distribution. So basically the PMF for the discrete uniform distribution is equal to 1/n, right? Yes, that is that. And sometimes we will be asked to calculate for the mean and variance of the discrete uniform distribution. If that is given to us, how are we going to tackle that? Suppose s is a discrete uniform random variable on the consecutive integer for a plus 1, a plus 2, to what? B, for where a is less than or equal to what? B. So how can we calculate for the expectation for our random variable x, right? Our expectation would be what? B plus what? A divided by 2. Note, we are saying that a is less than b. That means that our b will be what? Our upper limit, and our a will be our lower limit. So we are going to add the upper and the lower limit to and divide it by 2 to get what? Our expectation. Okay? And for the variance, we are trying to say that for the variance of the discrete uniform distribution is equal to b minus a plus 1 all squared minus 1 divided by what? 12. So when you have this formula in mind, and then we are asked to calculate for the variance for the discrete uniform distribution, this is what we are going to use. But note, the variance formula only holds, right, when we are our sequence is what? Consecutive integers, right? If it is consecutive integers, right? If our a and then b, as you see, is not a consecutive integer, then we can use this formula for the variance, right? If it is not a consecutive integer, we will use this formula: n squared minus 1 times d squared all divided by what? 12. This is the formula we are going to use if our if our observation are not what? Consecutive integers. Okay? And then sometimes too we may be asked to generate function, that is moment generating function for the discrete uniform distribution, right? So the moment generating function for the discrete uniform distribution is e raised to the power t bracket open e raised to the power n times t minus 1 all divided by n bracket open e raised to the power t minus 1. So this is what? The moment generating function, right? This is how we can generate moment generating function for the discrete uniform distribution. And you know, sometimes too we can be asked to also generate a characteristics function for the discrete uniform distribution. And for the characteristics function, that one too will be e raised to the power it, right, bracket open e raised to the power nit, right, minus 1 all divided by n bracket open e raised to the power t minus 1. Okay? Yes. So this is the characteristics function too for the discrete uniform distribution. So the only difference between the The moment generating function, the characteristic function for the discrete uniform distribution is the introduction of what? The i's, right? You can see that here is e raised to the power I times what? T. But here was e raised to the power t. So anywhere we see the t, we include what? I in that place to represent what? The characteristic function for the discrete uniform one distribution. So this is what the basic knowledge that you have to know under the discrete uniform one distribution. In our next video, we are going to solve work examples on the discrete uniform distribution for you to really better your understanding on that. So please don't forget to watch the videos on the work example. Thank you. Bye. Have a lovely day. Don't forget to subscribe to this is Statistics and Mathematics YouTube channel. Bye.